Hello! How do we condense and expand logarithms? Well, first let's go through some of these properties. First up, we have the product property that says that the log base b of xy can be split up into the log base b of x plus the log base b of y. Next up is quotient property, and notice if we can split multiplication into addition, then we can split division into subtraction. Log base b of x minus log base b of y. Lastly, the power property says that if you have log base b of x to a power, then you can just move the power to the front and multiply the log. So again, multiplication becomes addition, division becomes subtraction, and powers become multiplication. So let's try to use these. Here we have log base 2 of 16x to the 5th over y squared. So what we're going to do is break any multiplication into addition, and anything in a denominator will get subtracted. So here we have log base 2 of 16 plus log base 2 of x to the 5th minus log base 2 of y squared. Notice that whenever you're expanding logarithms, every single part gets a log base 2. And the minus is in front of the y squared because the y squared was in the denominator. Now I need to get rid of these powers. The powers get moved in front of those logs. So we have log base 2 of 16 plus 5 log base 2 of x minus 2 log base 2 of y. Something that I'd like you to think about is that we could have written this as 16x to the 5th y to the negative 2. And if we would have brought this power of negative 2 down, that's where we get that subtraction. All right, we're almost done. It's just that log base 2 of 16 can be simplified. And log base 2 of 16 is equal to 4 because 2 to the 4th power is 16. So our final answer is 4 plus log base 2 of x minus 2 log base 2 of y. All right, so with this problem, we have the natural log of x squared, and then all of this is in the denominator, the natural log of the cube root of 4x plus 1. Next, we can rewrite a cube root as a power of 1/3. Finally, the powers can move in front of the logs, and this is the natural log of 4x plus 1. These things are being added so that we can't break them up like we could multiplication. So this is our final answer. All right, for condensing logs, we just move the other way. The very first thing that we want to do is move all of the powers into their spots. And you'll notice that y raised to the half is the same thing as taking the square root of y. Now, because they all have natural log out in the front, these are all just one natural log, the addition becomes multiplication and we'll divide by the square root of y. So this condenses to the natural log of x minus 4 to the 6th times x cubed all over the square root of y. Here we have log base 4 of x plus log base 4 of y minus 2. And in order to condense this log, I need to express this negative 2 as a log base 4. So I think to the side, log base 4 of what number equals 2? Well, this isn't that hard to find out. You just take 4 and square it. So this would be 16. So now I can rewrite this as log base 4 of x plus log base 4 of y minus log base 4 of 16, which condenses to log base 4 of x times y over 16. All right, sometimes we have inconvenient bases, so whenever we're asked to evaluate, we have to use change of base. And so for log base b of x, we can rewrite this as log base a of x over log base a of b. And if we set a equal to 10, we can just rewrite that as the log of x over the log of b. Or I could set a equal to e, and I'd have log base e, or the natural log of x over the natural log of b. So let's use that to evaluate log base 3 of 5. I don't know, 3 to some power equals 5, and it's not like a pretty number. So I have to rewrite this as either the log of 5 over the log of 3, or I could also write this as the natural log of 5 over the natural log of 3. This is convenient because both log and natural log buttons are in our calculators. it doesn't matter which of these you use, you'll get the same answer, and you should get that this is approximately equal to 1.465. All right, and that's how we use change of base. Okay, that's everything with condense, expand, and change of base. Goodbye.